Hello all. Today we will be solving LeetCode daily question. So this is a problem statement. Let me go through problem statement once, and I'll take an example and I'll explain with an example and with a full edge cases. So what is the problem statement that they have given? So they have given an n by n integer matrix. So for that n by n integer matrix, we need to do some operations such that we'll get some output. So that is what they are asking. So the operation is choose any two adjacent elements of matrix and multiply each of them by -1. Right. This is the operation that we need to do on that two 2D matrix, and we have the freedom that we can do this operation n number of times. Okay, so what is the constraint that they mentioned? Two adjacent elements. So two adjacent elements means they should definitely have a border between them. So it is not like it is only vertical or horizontal, so it can be both. So I'll explain how it will be in the example. And our goal is to maximize the summation of the matrix elements and return that maximum sum of the matrix elements. So after doing this operation, uh, we need to maximize our matrix sum such that the sum of matrix elements sum is maximum. So these are the two examples that they have given. I will take another example which will best suited for explaining all edge cases for this. So let me jump into my screen. So this is the best example that I have taken. So we'll divide the problem statement into three categories. One is input, what they have given, and three is output, what they want, and in between there is second operation that we need to do some operations such that it will produce this output, right? So if we follow these three steps to solve any problem, I think it will solve 30 to 40% of our problem, because this will give clear idea about our problem, right? Let me just erase this. And okay, so this is a problem that I have taken, and in this, let me tell you the operation how it will be. So they mentioned it should have a border, right? So what is meant by border? So you need to select adjacent elements. So the selected elements in which you choose, the element should be adjacent. So that means they should be side by side. So one case is that like this, 1 comma 2. So this is one border and both of them are adjacent. So if we have like this, if you choose 1 and 3, if you choose 1 and 3, then they are not adjacent because they don't have border common between them. So that is why they mentioned you need to choose adjacent. So that is the operation that we need to do. So I explained here vertical, and it is horizontal. So it can be vertical also, like this also. One, two, in between there is a border. So this is also one of the case that we need to take. So it can be in vertical or horizontal. That is clear from the problem statement. Okay. So that is the main operation that we need to remember while doing these operations. So if you carefully observe this and do some mathematical, like if you multiply with -1, so this is the operation that we need to do. So if you choose adjacent elements, then you have the right and freedom to multiply it with -1. So it is not like you will choose 2 and you will perform -1 operation with one element. So you need, if you choose two elements, two adjacent elements, then you must multiply it with -1. So that is the operation. And so if you carefully observe here, so let me do this. If I choose, this is the row, and -1 comma 2 comma 3 are the elements. So if I choose this first row, it has -1, 2, -3. Okay. So this in this row, if we carefully observe, so we need to, if we want to maximize our sum, then we'll definitely have to reduce this -1 and -3 like that. If we can make it to 1 and 3, then our sum will be maximized, right? So how can I do this? If you can carefully observe and apply the operations, so you don't have limited operation, you can perform n number of times. So I can make these two adjacent by applying n number of times the given operation. So let's suppose I will apply for this two, then it will become 1, it will become -2, and -3 will remain -3. Okay. Now if you can carefully observe, here -1 is there. So I made this minus to this minus adjacent. So if both of them are adjacent, means in one operation I can make both of them to positive. Okay. So this is -2, this is -2. I can apply -1 operation, like if I can multiply with -1, then it will become positive, that is 2 and 3. Okay. So in this way I can do for row. So the same way I can do for column also. So let's suppose I choose -4, -1, 4, -7. Then I can first choose these two, and I can perform operation, just multiply with -1, then it will become 1, it will become -4, and this -7 stays. So next operation, if I perform this, if I multiply with -1 for these two, then they both become 4 comma 7. So in that way I can make both of them to positive. So this is how you need to do. So for that purpose, if you can carefully observe, let me erase this and take each one. Here, if I can count how many negative elements are there in this row, and I can do something with that. Let's suppose, first take this -1, -1 comma 2 comma -3. Then what is the count of my negative elements? So it will be 2, right? So no matter where these negative elements are there, if I have any two elements in my row, then I can definitely make them to positive, no matter wha- what is the index of these two elements. I can make these two positive, definitely. So if I have one element negative, then I might not able to do that, because we need to choose adjacent, and if you do adjacent, one positive and one negative, and if you do multiplication with -1, then it automatically reverses. So that will not make all the integers in the row if I have one uh, negative element which is not paired with any of the elements. So that is one observation I can take from this. And let me take this this last row. So -7, -8, -9. So this is the example. Mm, So what is the count of negative elements? It is 3. So in the previous observation, we have clearly stated that if I have uh, two negative elements in my row, then I can definitely make them to positive. So remember, using that rule, I can make these two elements positive, 8 and 9. And I could not make this -7 to positive because I don't have paired negative element with for -7. So that's why I could not make pair for this, and it will stay as -7 only. So we need to maximize. So what is the best way to maximize our sum? Because here -7, -8, -9. So I can choose any of them to make positive. I can make -7 and -8 to positive, and -9 stays. If I want to maximize my sum, then I need to make the negative element in which the negative element should be minimum. So in this case, you observe -7, -8, -9. If I do -8, if I do -8 and -9 positive, then -7 as negative, then my sum will be maximized. If I do -7 and -8 to positive, then -9 will be remains as minus 9 only. So that will makes my sum to be reduced. So for that observation, I will always make these uh, elements which are greater to be positive. And if I have negative, like here I can observe one thing, that if I have odd number of negative elements, then definitely one element will left out. So that one element should not affect the sum more. So for that purpose, I'll choose the minimum element among all these negative elements. So that is another observation I can take from this test case. So you can generally think like it is just first do this column wise and do this row wise, then you will get answer. So that will make sense. But if we have like this, the test case they have provided in this first one, let's suppose I have -1 1 1 -1. So in this case, I could not, if I can do row wise, then this -1 stays as -1 and this -1 stays as -1. And if I do column wise, then also it won't changes. So let me do some operations such that this -1 -1 will become positive. So I choose these two to become to perform the operation. Then this -1, then this -1 become 1, and this becomes -1. This is one operation I can do. And if you carefully observe these two, I can apply this -1 operation and I can make them to positive. So this row wise and column wise, uh, row wise and column wise choosing is not applicable. That means it will make some test cases correct, but for all test cases it might not valid. So for that purpose, this is one more key identification that we need to do. So using these operations, we can think of some logic that if I know, like if it is in the any rows or any column, if I have two elements which are negative, then definitely I can make them to positive. So that is a rule that we will understand from these three cases. One is row wise, and another one is column wise, and another one is diagonal. So you can take any example and try to do that. You can end up getting the two elements which are negative, they will definitely become positive using this multiplication with -1. So that is a key observation, and I can take from these three cases. So that will solve my problem. Let's take, let's count how many, uh, in this case, let's count how many negative elements are there. So I can take -1, -3, -5, -7, -8, -9. So the count is 6. Okay. So the count is 6, then definitely I can make every element to positive. Okay, I can make every element to positive. So you can choose -1, -3 to positive, and then -7, -8 to positive, and -5, -6 to positive, and -6 to -9 positive. So you can do that operation in any way, but at the end I will definitely make all these elements positive. So that is a key observation I'll do. Let's suppose I have minus instead of, let's suppose I have -6 instead of 6 here. Okay, then the count of negative elements will become 7. So in this case 6 will form pair and 1 will remains. So for this 6 we know how to do. So this 1 will remain, right? We need to make this one element such that the element should be minimum. Like if you have greater negative value means that will impact your sum. So in this case, what is the element that we can think of? -1, -3, -5, -7, -8, -9, -6. So out of this, if we choose -1, then our sum will be more. If I choose -9, then my sum will be reduced. So our goal is to maximize our sum. So if I choose -1, then I'll definitely have maximum possible sum out of this. So that is the edge case that we need to consider while doing this operation. So this is the logic part, and this is the test cases and edge cases for this problem. So let's do the code part of this problem. So they have given matrix and they have given the function. So the constraints mention that the matrix of ij is 10 power 5 to 10 minus 10 power 5. So if you generally do the sum of them, then it might exceed the int limit. So let's take long answer. So that's what they are expecting. So let's take long answer is equal to 0 and start counting the negative elements. So for that purpose, I am taking count is equal to 0 and starting it day of matrix for int of a. If x is less than 0, then I will increase my count and I will add its absolute value is equal to math dot absolute of x. Okay. So for the last edge case, I need to take the minimum out of these negative elements. So for that purpose, I will take min is equal to math dot min of min comma math dot absolute of x. So I declare here into min is equal to integer dot max underscore value. And at the end, if my count mod 2 is not equal to 0, that means if my count is odd, then I should definitely remove the minimum element 2 times because it is already added to my answer. So that's why I need to remove 2 times. Answer minus is equal to 2 into L of min. Okay, and there I will just return the answer. So I think it is correct. Let's try to run this. So, yeah, it is accepted. Let's try to submit. So it is giving correct answer. So this is how you need to solve this problem. If you understood